hazards. All right. I'm going to need to do a quick compass calibration before I can take off here. This one's a little finicky like that. Just give me one moment. They always like to say that the first thing you take flight before you fly a DJI is they like to get you dizzy first. I was what I was doing there was calibrating the compass at one axis and then another axis as part of that. So today I'll be flying a DJI Inspire 2 with an X4S camera as part of that. So it's a dual battery system, which is nice for redundant payload, or excuse me, for redundant energy. It also has self-heating batteries, and this one can go up to 50 miles an hour. It's built a lot for cinematography. We use it as a light mapping drone to be able to do a wide variety of activities. But I'm just going to do a quick tool around here today and keep it simple. All right. Launching. Something's not right. All right. So that's what we call an in-flight check, which it just failed. So this is wonderful as a demonstration purpose. Typically try to get up to a sustained altitude. Roll left, roll right, yaw, make sure it's behaving like you want it to or you've expected it to. However, on this one, it did not. So what I'm going to do is power cycle the device, try it again. All right, we're going to launch again. Mm-mm. right. Whoever gave 2 claps, I appreciate that very much. Thank you. All right. I'm going to try one more time. It's not quite behaving correctly, so we might have to go through recalibration. For sake of time, I'll probably just cede the rest of my time to Travis or someone else. Yeah, that's when I unmute. I'm going to take it offline. What I'm presuming is happening right now, if you notice, when I went up into the air, it kind of continued to ascend and didn't keep its GPS lock. What that lets me know is one of a couple things. One, I checked my controller configuration to make sure that I was in the proper mode for P mode on a DJI. Second, it let me know that there might be a need for IMU calibration, which will need to take place, and it'll take a few minutes in order to do that. So what I'm going to do is stop this right here. I'll go over to the side, calculate the IMU or calibrate the IMU, but I'll see the rest of my time to whoever's up next.
All right. Hey, Travis, you're up from WSP. So this will probably be the second drone that So the Wingcher is a pretty simple platform. It's got 2 batteries that go in the nose of the drone. The kit comes with 2 sets of 2 batteries. Extra sets are probably $600 a pair, so not actually compared to other.
Travis, you're gonna have to be uncomfortable and use the mic.
My bad. I'll move over there too. See, I told you I'm like a walking person. You can't track me down. So the batteries allow it to fly for about 48, 50 minutes or so. And batteries go in the nose of the drone. You can see the sensor here at the base is fixed in there. The aircraft has a little hood, as you've seen before, where the camera locks in there. So we got the GPS of the drone. So that's our PPK. Typically, you would have your static GPS, whether it's a Leica or one of those yellow things. I don't know what they call them. Just kidding, Trimble. Or Spectre as your static base cooking. Wingcher does not make any base stations. It's kind of nice. They stay in the realm of things that they like, which is drones. And you have your secondary party collecting static data that you post-process with. So the Wingcher does not connect to anything when you're flying except for the tablet. Set this out of harm's way. So the Wingtra's controller is pretty fantastic. It doesn't have any joysticks on it, which is kind of hard to get used to when you're a pilot that's used to taking off with the DJI Phantom forward, holding it to your crotch and letting it rip and knowing how to control a drone. Gotta keep you guys alive. So give me 1 second. Always when you fire something on, when people are staring at you, it takes a minute to get going. The drone does not have any buttons to turn it on and off. It's got the 2 power cables that you lock in the top. Once you do that, the sensor's alive and on. So again, it's kind of built from simplicity. The tablet is one that they give you. You can't bring your own tablet to the table. It has their flight software on it, which is actually pretty user-friendly. They've got a great online database of how to create flight plans, like a Wingcher training tutorial, a knowledge base. So when it comes to understanding the platform, you know, Human being someone who I taught to fly this system about 4 or 5 trips out on different projects and scenarios, you can become pretty comfortable with the platform itself. So what we're going to do is take the drone off. It does a vertical flight. It's going to transition at 200 feet to horizontal. At that point, you'll see it start kind of doing a lawnmower path. And I'll kind of talk myself through it, but give me about 1 minute to do a pre-flight check. I usually just like to have a little minute to make sure everything's good to go. So right now, what the drone is doing is there is a checklist on the left side of the tablet. As you turn the drone on, it gets a GPS lock. So it is actually on our screen. Right now, what it's doing is a camera check progress. Usually this is the one thing that'll fail if something fails. Basically, the solution is to power the drone off by pulling the cables, check the SD card and put it back in there. And she's still thinking. This usually happens, honestly, probably 1 in every 10 flights. You get a startup issue. So we'll give her a second to think. And if not, we'll do the standard, pull the batteries out, turn it back on. All right. So she actually said she's ready to go. So right now I'm uploading the flight plan. This is a fully autonomous flight plan. We're going to take off, go to an altitude of 200 feet, transition, then climb up to 400 feet, do a couple linear flight lines, snapping photos. At any time I can take over manually, pause the drone, tell it to go back to home, enact a loiter point in case we were to have an aircraft or helicopter fly by. We'll stop the drone. Fixed wings do have to stay moving the whole time. So I might actually do a practice of that so you can see how you'd pause the drone, but it still does flight. So right now to do a flap check. So it does check each servo motor on the left and right wing. It kind of says goodbye. Just there you go. Yeah, the shimmy, shimmy, shimmy. All right, the second to last thing says, are you fit to operate? I said, I am fit. Are you physically and mentally fit? I think we're there. That always cracks me up on this one. It's a checklist. All right, so battery life for 100%. Flight line's good. All clear. Taking off. So what it likes to do is get its belly in the wind so it actually knows which way a crosswind is coming. We're going up to about 200 feet right now. Transition. There's our transition. And it's going to kind of do a single corkscrew pattern to gain that extra elevation to get us to 400 feet. You do have the ability to determine at what altitude it does that transition. So if we had an obstacle at 300 feet, we could tell it to go straight up to 400 feet and then rotate. Usually I like 200 feet because that's about high enough that nothing is in its way. Human is my dedicated spotter. So as I was turning to you guys, just to point out, he is our line of sight. You all part of the flight team, by the way. So right now we're doing that second kind of curl up to the lane. I do have a preview of where the drone is at on the tablet. We do not see the imagery this camera is collecting. So it is kind of a two-part drone where the camera is being carried by the drone, but we do not see a live feed like Matt was with the Inspire. So we're on the first flight line here, and we've kind of started triggering photos right now. On my tablet, you can actually see it a progress status of how many photos you have to acquire. It just kind of right here. So one thing that the Wingtra does, and it's a good question, is it requires a large area to do bank turns. So if you were limited to somewhere where your vertical airspace had to be retained with the drone, a fixed wing may not be your best answer because it takes a wide turn, whereas a copter can stop on a dime, turn 90 degrees and stay in your vertical column. One thing really neat about the Wingtra is its ability to handle crosswinds. Any winds below gust of 27 miles per hour, the Wingtra can fly in. Your data is degraded by the quality of your crosswinds, but this system's smart enough to know if it's got crosswinds, how much battery life am I utilizing and how far is my home point. It'll actually let you know when it needs to come home. So this system's pretty sweet because if you use a large site, you just let it fly as long as it can until the battery gets to 33%. It'll tell you I need to come home. It comes home, put new batteries in it, and it starts right back. So it actually allows the pilot to be in charge of the airspace and not so much worrying about the drone itself. We got about one flight line left, but I'll do a pause and loiter here in a second just to show you what it would be like if we had identified a helicopter or a crossing plane that our flight line might be 3,000 feet and we want the drone to stop where it's at. So hit a pause and loiter.
Pausing and loitering.
So you'll see it does a tight, about maybe 50 to 100 foot circle, and it's going to stay in that same spot. I have the ability to go up or down by 30-foot commands. So if you imagine a helicopter was coming and he was maybe at 300 feet and I'm at 400, I can just hit the down button about 10 times and I'll drop down to 100 feet in that loiter. We've got clear skies. We're going to continue our flight.
Auto flight mode. Flying towards resume point.
Yep. So we've actually had a situation in the past where, say we had our pilots and team on a perfect visibility spot. There was actually a large dam above a lake and a tight riverbed. And there was a situation when some helicopters were flying very low altitude down that riverbed. So by the time you heard helicopters, identified them as a threat, we had about 30 seconds to do something with the wing chiller. At that point, we decided to take the wing chiller higher. So we were at 400 feet. Pause it, hit the up button as fast as you can, and it'll climb pretty quickly. About every second, you can get about 20 feet in ascending. So within a couple clicks, you can gain 100 feet in altitude. And some situations you think it's always best to come down, but otherwise you can always go higher if it's to avoid an incident. And then same thing as when the drone took off, we're going to go back to that loiter direction. So I can actually change this loiter direction on my tablet. So if we had a cell phone tower that direction, the drone would take off and do its corkscrew in whichever cardinal direction I choose on the tablet. So you have the ability to really tell this drone what you want to do. When we land, I'll let it do a full autonomous, but you do have the ability to take over manually if a vehicle was to park in your launch recovery area and move the drone when it's vertically ascent. So that was a 4.5 minute flight and we've got 94% of battery still. Luckily, we've got about 0 crosswinds. Otherwise, you'd see the drone kind of fighting the wind or possibly even at a 45-degree angle if you're taking off from the beach. So the drone will do such a great job in heavy crosswinds. So what's really cool is, that drone took off, say 10 feet behind that target, landed 10 feet in that direction. That's usually about the worst it'll do. It's usually tighter than that. So that was a fully autonomous flight. Just plan it out, let her rip. I can disconnect this to the drone and show you this flight plan once she's turned off. If that sounds good to anybody. Go. Took a minute for the camera. It was kind of weird. Yeah, I was like, oh.
Okay, guys, next we're going to set up the NCDOT Command Center for the Division of Aviation. They're going to set that up and we'll do a tour of their Command Center van. Be right back. So pull up with the doors as close to this camera as you can, because I can't really move this too much. Okay. Stand inside. So yeah, just back it right in here.
ain't in that bracket.
Check, check. All right.
All right, good afternoon, everyone. So DeAnthony and myself, my name is Fred. We are with NCDOT Division of Aviation. So we basically do all the drone work that DOT needs across the state. And we brought with us today our mobile command center. So we used to have to drive, you know, we cover the entire state. So we may have a job at the coast where we drive 3 hours and we fly, get the data we need, and then have to drive all the way back to the office to process all that data. To alleviate that time, we now have a mobile command center that we have Starlink internet. We also have a cradle point inside that gives us extra Wi-Fi. We've got 4 monitors inside. We've got a big screen TV on the back. We've got everything we need to fly the job, immediately hop in and start processing that data right on site, and then get it to the division engineers that need it to take it from there. It also helps with, we do hurricane response. So when we get hit at the coast pretty hard, it washes out a lot of those dunes, or if maybe 40 gets cut off, we can head out to that area and set up on site and have everything we need to be self-sufficient, fly for all of those projects out there, and then again, process that data and get it to everyone that needs it as fast as we can, because that's the name of the game. Everybody wants data immediately, so that's what we're working on. We also have an awning that comes out off the side just for hot days. It's nice being out of the sun. Up on top, there's a helipad, so we can launch and recover from the top. There's a ladder on the backside to get up there. Also, just sometimes getting up there to get that better line of sight, because as drone pilots, the drone always has to be in line of sight. So being an extra 11 feet up helps with that vantage point. D?
Yeah, like what Mr. Fred said, one of our main use cases for this is really like hurricane disaster response. And one of the cool things that we're able to do with this command center is have live streaming capabilities. So we can actually live stream, you know, the footage that we're getting and the results that we're getting. And from any type of disaster, or like we said, we go to the shores and we look at some of the dunes and see how before and after an event, like I know recently Hurricane Ian, how they're washed away, and we can live stream that data back to Raleigh or to whoever has the link, you know, and whoever needs that data. So yeah, cool. Yeah.
Perfect. Thank you, guys. I guess that kind of concludes the virtual online portion. We're going to continue to fly drones and demo out here, but thanks to our virtual people for being a part of the conference, and have a great day.